drive, a smart thermostat learn, or a pacemaker keep a heart beating perfectly, it's not magic. It's actually a hidden world of tiny, dedicated computers all around us. And today, we're going to pull back the curtain on this invisible intelligence. So take a look at this. It's a pretty normal living room, right? You've got your TV, a smart thermostat on the wall, a couple of speakers. So take a guess. How many actual computers do you think are in this picture? 1? Maybe 2? Well, the real answer is probably going to shock you. It's dozens. Seriously, they are tucked away inside almost everything that has a plug or a battery. And this, right here, is the world of embedded systems, the invisible intelligence that pretty much runs our modern lives. Okay, so what exactly is an embedded system? Let's break it down. What is this invisible intelligence we keep talking about? At its core, an embedded system is a purpose-built computer. It's this combo of hardware and software designed to do one specific job, and only that job, inside a bigger device. The most important words there are dedicated function. And this is how they're different from, say, your laptop. A PC is a jack of all trades. It can browse the web, play games, do spreadsheets, you name it. An embedded system, it's a specialist. It has one single job, like making sure your car's anti-lock brakes work perfectly. And because it's so focused, it can run on way less power and memory. And a lot of the time, it doesn't even have a screen or keyboard. And this idea of specialization gets really, really clear when we look at the tech that's making our own homes smarter. Let's bring this home literally. So let's talk smart thermostats for a second. According to Energy Star, getting a certified one can save you up to 26% on your yearly heating and cooling costs. That is a huge chunk of change, and it's all thanks to the tiny, dedicated computer humming away inside that little device. But here's where it gets interesting. Not all of them do it the same way. There are basically 2 competing philosophies for how they work. You've got the quiet assistant versus the hands-on command center. And this table just lays it out perfectly. The Google Nest, that's your assistant. It uses machine learning to quietly watch your habits and build a schedule for you. It's the definition of set it and forget it. But then you have Ecobee, which is the command center. It uses all these remote sensors to know the temperature and if people are actually in the rooms, letting you decide exactly what to prioritize. It puts you in the driver's seat. Okay, so let's step out of the living room and into the garage. Because a modern car, well, it takes this whole concept to a completely different level. Your car is probably one of the most complex computer networks you will ever own. 100 million, no. That's not a typo, that's how many lines of code can be running inside a modern car. It's not just an engine on wheels anymore, it's a super sophisticated rolling data center. And all that code is running on more than 150 separate little computer systems. I mean, think about it. You've got driver assistance systems processing camera data, anti-lock brakes calculating grip, airbag systems waiting to deploy in an instant, and in an EV, a battery system that is obsessively monitoring every single cell. And they all have to communicate and work together perfectly. And here's the absolute crucial point. These aren't just cool features. They are safety critical. They are real-time systems. An anti-lock brake controller doesn't have time to buffer or think. It has to react in milliseconds. Any delay, even a tiny one, could be the difference between a close call and a catastrophe. That life or death timing brings us to probably the most important place we find these systems: medical technology. This is where the tech isn't just convenient or for safety, it is literally a lifeline. One does mean you have to be aware of the world around you, and these are some of the big do's and don'ts. Everyday electronics can create interference, so keeping your phone at least 6 inches away, being careful around strong magnetic fields, and always letting airport security know these are absolutely essential things to remember. And this brings up a very modern question, right? With so many of us wearing smartwatches and fitness trackers, is it safe to wear one if you have a pacemaker? And the answer is, you really have to be careful. The issue comes from a feature called bioimpedance technology. It sounds complicated, but basically some watches use it to measure things like body fat by sending a tiny, unnoticeable electrical current through your body. Well, that little current could potentially confuse a pacemaker, so caution is definitely needed. All right, so we've seen just how deep this technology runs in our lives today. So what's next? Let's take a little peek into the future of this invisible intelligence. This gives us a great roadmap. We're heading towards something called Edge AI, where devices can make really smart decisions on their own without needing the cloud. Think a car that can see and react instantly.
We're also looking at 6G connectivity, which will let billions of devices talk to each other in real time. And then there's green computing, which is this wild idea of powering devices by pulling energy from their environment. So no more batteries.
But of course, there's a flip side. This amazing connectivity, it comes with a catch. Every single smart device in your world is a potential backdoor for a cyber attack, and the amount of data they collect brings up some really serious questions about our privacy. Securing this invisible network is, without a doubt, one of our biggest future challenges. And that leaves us with one final and pretty heavy question to think about. As our homes, our cars, and even our own bodies become more and more connected, who's ultimately responsible for the invisible intelligence that runs our world? That's something we're all going to have to figure out together.